Swayam Prabha. Digital India. Educated India.
Welcome back, learners. The video is for the subject of Geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honours in Geography. The video is for the paper of Climatology. Today we will be starting with Module 5, Air Masses. In this lecture 1, we will be discussing today air masses, meaning and classification. The video is being recorded by Dr. Pallavi Upreti. The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayamprabha Channels of MHRD, New Delhi, India. Hello dear learners, I am Dr. Pallavi Upreti, Assistant Professor in the Department of Geography in Dr. Nityanand Himalayan Research and Study Center, Doon University, Dehradun. In our previous video lectures, we have already discussed several atmospheric conditions, patterns, and phenomena. In this particular video lecture, we will be starting with air masses, which is a very important atmospheric phenomena and impacts climatic conditions and weather patterns across regions around the world. So let's begin. The main objective of this particular video will be to understand what air masses are. What are the prominent characteristics of air masses, the source region of air masses, the classification of air masses, how air masses move, and which are the areas which are affected by air masses. And finally, how air masses influence the weather and normal climatic conditions of a particular area and even globally. So let's begin. Earth's climate and weather is controlled by a variety of factors. One of the most important is Earth's air masses. In general, air masses are huge parcels of air with specific characteristics. Specifically, an air mass is a large volume of air in the atmosphere that is mostly uniform in its temperature and moisture conditions at any given altitude. They are extensive in horizontal and vertical dimensions. An air mass can be so extensive that it may cover a large portion of a continent, and it may be so thick in vertical dimension that it may vertically extend through the troposphere. It may be also pointed out that since a single air mass is so large of Earth's surface, hence after a certain point of time, the physical properties may also get altered. Therefore, the air mass extends over continents and oceans as well. And since they extend horizontally to hundreds of kilometers over the Earth's surface, their horizontal homogeneity after a certain point of time is not possible. The movement of air mass is also associated with several global atmospheric phenomena and weather patterns, especially along the higher latitudes. Before understanding what are the major characteristics of air masses, let's look at few definitions of air masses given by different scholars. Barry and Sholay defined air mass to be an air mass may be defined as a large body of air whose physical properties, especially temperature and moisture content, lapse rate are more or less uniform horizontally for hundreds of kilometers. Another definition given by Stroller is a body of air in which the upward gradient of temperature and moisture are fairly uniform over a large area and is known as an air mass. So air mass may cover hundreds of kilometers of distance horizontally. At a given altitude, its physical properties, specifically temperature and humidity, water vapor content, remain same. But when air masses are formed, they tend to travel to different regions. After traveling hundreds and thousands of kilometers of area, in the process, the air masses themselves are also modified. And when they travel to different areas, during their travel time period, they also alter the physical conditions of the underlying surface. So air masses may extend horizontally to thousands of kilometers, and in the process, they alter the temperature of those areas, and as well as themselves get modified in the process also. Now let us look at some of the characteristics of air masses. Firstly, an air mass is a large unit of the lower atmosphere defined by common physical characteristics such as temperature and humidity at a given altitude, and one that remains discrete and identifiable as it moves. Air mass have fairly uniform temperatures and moisture conditions over a large horizontal surface at a given altitude because they are not vertically uniform. However, they are horizontally uniform to hundreds and thousands of kilometers over the surface of Earth. Next, we have the properties of air mass are determined by the underlying surface properties of the regions from where they originate, which are called as the source regions of air masses. So, the parcel of air remains stagnant over a particular region for a very, very long time period. And during that time period, it tends to replicate the properties of cold, hot, underlying source region from where they originate. Therefore, the properties of air mass are defined by the underlying surface of regions from where they originate, which are normally called as the source regions. Once the air masses are formed, they tend to migrate to different region and they circulate within the general atmospheric circulation. Upon movement, the air masses displace the residual air over the local region, changing the temperature and humidity characteristics of that particular region. And movement of air mass out of their source region also tend to modify the air masses themselves in their journey from one place to another. So air masses are immense, huge parcels of air which remains homogeneous for thousands and hundreds of kilometers horizontally. But after a certain point of time, they may also get modified in the process and they may lose a bit of a character after traveling to hundreds and thousands of kilometers, and in the process also gets altered. There are certain regions on the planet from where the air masses originate. So these regions are called as the source regions. The zone that birth the air masses, which are most prevalent in the tropics, subtropics, and higher latitudes, are called as the source regions. And they are typically areas of uniform surface, tracts of ocean, deserts, or snow-covered plains whose nature and physical properties largely determine the temperature and moisture characteristics of air mass. So these areas are so extensive. They may be over land, they may be over water. These areas are so extensive that their properties are absorbed by the parcel of air which is lying above them, which becomes an air mass, and therefore the air mass's characteristics and properties also define the characteristics and properties of their source regions. They may also be areas which experience general weak winds, stable condition that allows the parcel of air in the atmosphere to assume physical characteristics from the underlying water or land surface. So the air mass source region primarily occurs in the higher or lower latitudes because of the stable conditions in those areas, the less mobility of air in those areas which allow the air mass to sit over that land surface for a very, very long time period and attain its properties. These source regions and Their prevailing temperature, humidity, and stability classify the world major air masses. So when we talk about the air masses, their characteristics, we definitely through their characteristics can also understand what are the source regions of air masses. An ideal region for the development of the air masses may have these conditions which leads to the development of air masses. The area can be extensive, uniform Earth's surface, extending for thousands of kilometers horizontally on the surface of Earth. The area can either be land or water depending upon the source region. The area can be land or water. The area experiencing divergence of air leading to atmospheric stability, allowing the parcel of air to sit over that land surface for a very long time period. And finally, the atmospheric conditions should be stable for a very long time period, facilitating the transfer of properties, the transfer of conditions from the lower lying land surface to the parcel of air which is lying above it. So the source region ideally are very extensive continental tracts or very extensive water tracts. What's interesting about the characteristics of the air mass is not only do they describe it, but also highlight the source region on Earth. For example, they can originate over continents as well as they can originate over the oceanic surfaces. The air mass generally originating over the land surface or land area are called as continental air mass. These air masses are generally dry and do not have that much of moisture content in them, whereas the air masses originating from the water bodies from the oceanic surfaces are called as maritime air masses. These air masses are generally laden with moisture content and they are moist in nature as compared to continental air masses. The air masses are also sourced from different regions along sea latitude. For example, the air masses originating from extreme northern and southern polar regions are called as the Arctic air masses, which generally originates over very cold areas, typically continental and maritime areas of the Greenland and Antarctic region and the Arctic basin. Further south to Arctic region is the polar region, which also source various air masses. And these air masses generally are sourced from very cold regions of Canada, Siberia, northern Atlantic Ocean, and northern Pacific Ocean. And similarly, in the southern Pacific Atlantic Ocean also. Besides this, we have air masses which originate within the tropics, which are called as the tropical air masses. So the air masses may originate over continents and oceans, which is defined on the basis of their moisture content, because the continental ones are drier and the oceanic ones are comparatively moist. And the air masses may also vary according to their latitudinal distribution of planet. They can either be Arctic, polar, or tropical. Based on their location and the source region, the air masses are therefore named according to their source region, and they are denoted by the capital alphabets: A for Arctic, P for polar, T for tropical, and sometimes the air masses also originate from the equatorial areas. Therefore, a capital E is used to denote such type of air masses which originate from the equatorial areas. And as we have also discussed that the air masses originate from the continental areas and the ocean areas depending upon their moisture content. So in order to denote whether they originate from continents or oceans, lowercase alphabets are used as C and M based on the moisture content. Based on the geographical location of origin of air masses, there are majorly 6 source regions which exist. As we have already discussed that they may originate from the polar areas, they may originate from the tropical areas, the Arctic areas also, and they may also originate from the continents as well as the oceans. Therefore, based on all these characteristics and their originating sources, the air masses are mainly divided into 6 major source regions. First is the polar ocean areas which are located in the polar areas, and then we have the continental areas which are located in the polar areas. Similarly, we have the oceanic areas which are located tropically, and the continental interiors or the continental areas which are located tropically. Further, in the lower latitudes, we also have some monsoonal lands of Southeast Asia which originate the air masses, and also the air masses originate from the equatorial regions. So altogether, we have 6 major source regions from where the air masses typically originate. Now, coming to the classification of air masses, based on the temperature and moisture conditions of their source region, since we have already discussed that the air masses characteristics not only define the air masses themselves, but also the characteristics of the source regions. Therefore, the air masses characteristics are also symbolic of their source region, and hence, while classifying the air masses, the temperature and moisture conditions of their source regions becomes very, very important. Based on moisture content, the air masses, we have already discussed that it can be dry, originating from continental areas, and they can be moist, originating from the oceanic surfaces. And based on temperature or based on their latitudinal location, the air masses can be divided into Arctic, which are extremely cold regions located in the northern and southern polar regions. And then we have polar areas originating the air masses. And then we have tropical areas located within the tropics. And finally, we have the equatorial areas, which are the warm regions leading to the development of the air masses. In order to understand the air masses in a better way, there are naming symbols which are used, as we have also quickly seen in the earlier slides. The naming symbols are used to define the air masses, which are symbolic of the regions from where they originate, the regions with typical moisture and temperature conditions. For example, for dry continental areas, we use lowercase of alphabet C, and for the moist oceanic maritime regions, we use the lowercase m. But for defining the regions like Arctic, we generally use uppercase letters, which is A in case of Arctic, P in case of polar areas, T in case of tropical areas, and E in case of the equatorial areas. So based on all this nomenclature and the characteristics of the source region, the air masses can broadly be divided into 3 categories. First, the Arctic air mass denoted by capital letter A. Then we have polar air mass denoted by capital letter P. And then we have tropical air mass denoted by capital letter T. Sometimes within the tropical air mass, we also see subcategory, which is the equatorial air mass, which are generally described by capital letter E. And further, each category is divided into 2 sections based on whether they originate from continental areas or the maritime or oceanic surfaces. So they are further divided into 6 categories primarily. The Arctic air mass is divided into continental Arctic air mass denoted by Ca, and then the maritime Arctic air mass denoted by Ma, where the maritime Arctic air mass seldom exists, and these types of air masses are very, very rare. Therefore, this particular category is often not considered, and the air masses are generally considered to be 5 only. Further, the polar air mass category is divided into the continental polar air mass and the maritime polar air mass. And in the tropical regions also, the air masses are categorized into the continental tropical air mass and the maritime tropical air mass. So this is the broad classification of air masses based on their moisture content and based on the temperature or latitudinal location from where they originate. The location of different air masses and their source region can also be seen from this particular map, wherein you can see that the continental Arctic air masses are mostly located over the continental surfaces in the Arctic region, and we rarely have the maritime Arctic type of air masses because the Arctic or the ocean surfaces do not get extremely cold as compared with the continental areas. So the characteristics of the Arctic regions are often associated with the continental air mass mostly. Then you have the continental polar air masses, which often originate from the continental interiors, very cold continental interiors of Siberia and continental interiors of Canada also. Besides this, we have also maritime polar air masses originating from the higher latitudinal oceanic regions in the Atlantic and the Pacific Oceans primarily. And you also have maritime polar in the southern hemisphere also, you can see in this particular map. Besides this, we also have the air masses originating from the tropical areas within the tropics. So they can originate either over the oceanic surfaces, making them maritime tropical, and continental surfaces, making them continental tropical. Similarly, in the southern hemisphere also, you can see the maritime tropical and the continental tropical. Sometimes within these tropical areas, the air masses also originate from the equatorial areas. So you also have maritime equatorial air mass originating from the equatorial regions, particularly between the stable regions of equatorial areas. As we've already discussed, the areas which are located over the equator. So we have different air masses, and based on their source region, they can be divided into 6 categories, which we have just discussed. Moving on to the detailed description of each category of air mass, first we have continental Arctic air masses, because the Arctic air masses are divided into continental Arctic and maritime Arctic. And we will be taking continental Arctic now because maritime Arctics exist very, very rarely. So continental Arctic air masses represent extremely cold and dry conditions, and they are mostly located in the extreme northern and southern polar regions. They originate over snow regions of Arctic Basin, Antarctica, and Greenland ice cap, as you can also see in this particular diagram. They primarily originate in these particular areas. The boundary between the continental Arctic air mass and continental polar air mass is very, very shallow, forming a boundary which is primarily called as fronge, which we will discuss in the next video. Once formed, they move and bring extreme cold and chilly weather and dry conditions to the regions. So once they form, they tend to migrate, and in that process, they bring chilly conditions to the other regions where they move. Now coming to the continental polar air mass are dry, cold, stable air masses originating over snow-covered regions of central Canada, Alaska, Siberia, etc. So these originate from the extreme cold and chilly areas of the continental polar regions, okay, and generally 60 to 75-degree latitudes they originate, and they also originate over the ocean surfaces, as you can see, maritime polar, so northern oceanic or high latitudinal oceanic surfaces. So you have continental polar, and then also you have maritime polar air masses, which are very, very cold and moist air masses originating in upper latitudinal oceanic regions. They move in south and southeast direction in the northern hemisphere once they are formed, and bring showers to the coastal areas. They became warm and unstable, leading to the precipitation in western coastal areas of most of the continents. So they may move east, or they may move west, bringing the changes in the climatic and weather conditions of the coastal area. So as you can see, the maritime polar type of air masses developing over the upper latitudinal oceanic regions on the Earth's surface. Further, we have continental tropical air masses. So in the tropical regions also, the air masses are divided into the continental tropical ones, which originate over the continents in the tropical areas, and the maritime tropical areas, which originate over the tropical ocean waters in the tropical regions. So mainly the continental tropical air masses is a summertime phenomena exclusively existing over desert and dry land areas of the tropical regions. So you can see that they originate over the dry regions of the continental areas. They are unstable, however, clear condition exists due to the lack of water content in them because they are comparatively drier as they originate over the continental areas. However, they may lead to thunderstorm when forced to uplift. Besides this, we also have maritime tropical air masses which are formed over the low latitude ocean surfaces. As you can see, maritime tropical air masses originating over the Indian Ocean, the Pacific Ocean, and the Atlantic Ocean, and certain parts of the Indian Ocean also. Moving over, they are warm, moist, and unstable, capable of yielding heavy showers on striking the ground surface and even over the oceanic surfaces. Moving over warm continents in summers, the high heat and high moisture may lead to dramatic weather patterns and conditions followed by heavy showers in the continental coastal areas. They have enormous influence specifically over the climatic conditions of USA in particular. Finally, we also have the equatorial regions from where the air masses originate, and they typically originate over the extensive ocean surfaces found in the equatorial areas. Therefore, they are again warm and moist, and they also bring the changes in the weather and climatic conditions of the equatorial regions and adjacent areas. So based on the characteristics of air masses, based on the characteristics of their source region, based on the moisture content, based on the area from where they originate, their temperature, the air masses can broadly be classified into cold air mass and warm air mass. So what is a cold air mass? It is termed cold when the temperature of the air mass is lower than the underlying surface. So once the air masses originate, it takes on the properties of the underlying surface and becomes very, very cold over a particular time period. So much so that at one point of time, it becomes cooler than the underlying surface. And once they are formed, they tend to move out from their source region. So such cold air masses originate primarily in the polar and the Arctic regions of the world, hence cold and dry. Once formed, they travel away from their source region, travel over warmer surfaces, and are heated from below in their journey, in their process, and therefore they become unstable. Once they become unstable, they start moving upward because warm air wants to rise, resulting into condensation, cloud formation yielding precipitation. So cold air mass, if they contain sufficient moisture, they may also yield precipitation. So cold air mass is the air mass which has temperature lower than the underlying layers. Mostly the cold air mass tend to move to warmer regions, and in the process they become unstable, yielding immense precipitation if sufficient moisture is present in them. Besides cold air masses, we have warm air masses. Warm air masses are termed warm when the temperature of the air mass is greater than the underlying surface. And in such conditions, when the warm moving air masses passes over the cool land surface, it is cooled from below, resulting into atmospheric stability because the cool air tends to subside, bringing atmospheric stability, bringing dry conditions, not yielding precipitation. Therefore, it restricts upward movement of air, retarding precipitation, and dry conditions prevail in such areas. But the mixing of cold and warm air mass is not easy, and in the process they create immense atmospheric frontiers called fronts, and these fronts are mainly formed in the higher latitudes because the difference in the properties of air masses is very huge. Therefore, the air masses coming from north are very cold, whereas the air masses existing in the lower latitudes are comparatively warmer. Therefore, they don't tend to mingle very easily, creating the atmospheric barriers called fronts. We will be studying about the fronts in the next video, but you must understand for now that the cold and warm air mass, when collide together, they don't mix easily, creating the atmospheric frontiers, barriers at the point of their collision, which are called as fronts. And these fronts are very important in defining weather patterns and atmospheric conditions in the higher latitudes. Once the air masses are formed in their source region, they tend to migrate outward to different areas, and in the process they are modified themselves and modify the temperature and atmospheric conditions of their lower lying surface during their journey. Therefore, the modification of air mass occurs mainly due to heating from below, then from evaporation of water into air from below, or into intermediate layers by precipitation from moist air aloft. So they are thermodynamically modified while moving out from their source region, and in the process they are modified due to several atmospheric and weather conditions which are existing on our planet. And because they have immense horizontal dimension, they tend to influence the climate and weather patterns of various areas over which they travel. Therefore, the modification of air mass depends upon the initial characteristics of air mass. What was the temperature of the air mass once it was formed? What was the moisture content? For how long it was sitting over the source region? How immensely it has acquired the properties of the source region, and it have its initial characteristics. Second is the nature of land or water surface over which the air mass moves. So definitely the source region definitely defines the type of air mass, and the modification of air mass also depends whether it was coming from a warmer region, it was coming from a colder region, whether it was developed over the continental interior, or whether it was developed over the moist ocean surface, whether they were developed in lower latitudes or higher latitudes. So all these factors definitely matter during the modification of air masses during the entire course of its journey and travel. Third is the path followed by the air mass during its movement. It was also an important factor when you consider when and how air masses are modified. When, for example, if a continental polar air mass are formed over the continental areas, they tend to move southward in the northern hemisphere, and therefore they bring chilly cold conditions to the continental areas over the northern hemisphere. Therefore, the path, and also so during their course southward travel, if there is a large ocean body, they will pick up moisture from that ocean body. They may also yield precipitation at certain points. Therefore, the path followed by the air mass during its movement also important for its modification, because it may change its moisture content, it may change its temperature. Hence, the path followed is also very important. Third is the time taken by the air mass to reach a particular destination. If the air mass travels very fast, it may not acquire the property of the underlying surface. and also may not be able to influence the underlying surface also. So the time taken by the air mass to reach a particular destination is also very important in understanding, in knowing how the air masses gets modified in their journey. So these are the four main factors which leads to the modification of air masses over a period of time during their travel. An air mass may sit over its source region for a very long time period, and after a point of time they may migrate also. An air mass on the move begins to transform as it passes over new landscape, while at the same time retains enough of its original condition to alter the local weather also. For example, as you can see here in this slide, that the continental polar air mass originating from the tundra of northern Canada may push southward in winter, bringing very cold frigid temperature conditions to the continental interiors of United States during its course of journey towards the lower latitudes. So they modify the temperature and local weather conditions of the area. Besides this, the air masses originating from the dry source regions often pick up moisture during their movement. So their path of movement is also very important. For example, the continental polar air masses originating from the continental interiors of Canada upon its movement pick up moisture from the Great Lake region of America and allowing it to dump the so-called lake effect snow and level coastal condition, bringing precipitation to many areas which otherwise do not receive precipitation. Therefore, the movement of air mass is important in bringing the much needed change in weather and climatic conditions of an area, and also in the process the air mass, the properties of air mass, the temperature and moisture conditions of air mass may also get altered. So once the air mass is formed, it tends to migrate outward from its source region, bringing the changes in the atmospheric conditions of the underlying area, as well as their own self is transformed while passing over the newer landscape, where they acquire the properties of the underlying surface and they are modified because of the existing geographical conditions during the course of their journey. The formation of air masses, the movement of air masses and their migration definitely influence the weather and climatic patterns on our planet, because these giant air parcel extends for hundreds of kilometers, exerting significant meteorological and climatic influence, transporting characteristics of their originating region through the territories they move over. So they bring out the characteristics, they bring out the atmospheric conditions of their source region to the territories they move over, and in the process they immensely modify the weather conditions of the area. When winds move air masses over, they carry their weather conditions, which includes whether they are heated or they are cold, they are dry or moist, from the source region to a new region, leading to either atmospheric stability or instability in the atmospheric condition depending upon their initial characteristics. So when air masses upon their movement may bring the stable conditions. For example, if the air mass is very cold and chilly, once they are formed, they move out of their source region. In the process, they get warmed up because they move outwards to the warmer regions, and in the process they are warmed up. The warm air becomes unstable and yield precipitation. Similarly, if you have warm air mass, the warm air mass tends to migrate outward from the warmer regions to the cooler regions, and in the process the warm air mass becomes cooler from below, attaining the properties of the underlying cool surface and therefore bringing the stable conditions, bringing the atmospheric stability in the particular areas over which they move. Besides this, air mass affect the weather in many ways. For example, a polar continental air mass causes cold and frosty weather conditions upon their movement, bringing the chilly effect of their source region to the lower latitudinal regions. And similarly, the maritime air mass contributes to moderating climate by yielding precipitation in the areas which it influences and over which it travels. Especially in the coastal areas, it brings out the moderating effect by yielding precipitation. Besides this, the air masses, because of variable properties, because of variable temperature and moisture properties, may not be able to mingle together very easily. Therefore, the thresholds of adjacent air masses varying in their physical properties leads to the formation of the atmospheric frontiers called fronts, along which much of the world's major weather action takes place, including cyclones and extreme weather conditions. So when the cold air mass travels over a warmer surface and collides with the warm air mass, because of differences in their physical properties in terms of temperature and moisture conditions, they are not able to easily mix up, leading to the formation of what we called as the atmospheric barriers and called as fronts. So especially in the higher latitudes, these fronts play a very significant role in controlling the weather and climatic conditions of the region, and also specific climatic conditions like the formation of cyclones and extreme weather conditions like the formation of tornadoes in many places is also associated with the travel, movement, migration and formation of air masses, specifically in the higher latitudes. So air masses here you can see that influence the weather and climatic conditions of many areas across the globe, and they affect the general circulation. So air masses traveling within the general circulation of our planet tend to influence the weather and climatic conditions of areas across the latitudes on our planet. So summarizing the video, an air mass is immense body of air that is characterized by uniform temperature and moisture conditions throughout at any given altitude. Why given altitude? Because their properties, their physical properties, their temperature and moisture may not remain uniform in its vertical dimension. However, for thousands of kilometers, uniformity in temperature and moisture conditions may remain homogeneous. However, even after traveling thousands of kilometers horizontally also, the air masses may tend to change their initial characteristics a bit. They develop over large uniform spaces which can be over continents as well as oceans, and primarily in the higher or lower latitudinal regions of our planet, because mid latitudes are too variable, characterized by the unstable atmospheric conditions which do not favor the formation of air masses. So they are primarily formed over the higher or the lower latitudes of our planet. Once they develop, they move in the process, they influence the climate conditions of the area from where they pass. They may bring cold, chilly climatic conditions, they may bring precipitation to the areas over which they move, and in the process they also gets modified due to the underlying surface, because traveling thousands of kilometers out from their source region, they tend to lose their initial characteristics and acquire the properties of underlying surface during their course of journey. The air masses, depending upon the source region, are broadly divided into Arctic, polar, tropical, equatorial air masses, depicted by capital letter A, B, D, E respectively, and they are further divided on the basis of moisture content, where they are divided as dry, depicted through lowercase c letter, which develop over the continental areas, and moist, which develop over the maritime or oceanic surfaces, depicted by lowercase m letter. So based on this nomenclature, they are primarily divided into 5 categories, that is continental Arctic, continental polar, maritime polar, maritime tropical, and continental tropical primarily. And we also sometimes have the maritime equatorial air masses also. Besides these five categories, we also have the maritime Arctic type of air mass, but they are very, very rare. Therefore, we only consider the five major categories of air masses. Otherwise, there are six categories theoretically. Six categories. The air masses once formed try to migrate to different regions, and in the process they immensely impact the weather conditions and climatic conditions of those regions particularly, and throughout the world also they have a significant impact on the climatic conditions, especially in the higher latitudes due to the formation of active boundary zones between the contrasting air masses, which are called as fronts. So these frontal areas are regions of immense climatic turbulence, and they highly impact the weather and climatic conditions, especially in the higher latitudes. So in this particular video, we have seen what is the definition of air masses, what are their source region, what are their major characteristics, how they are defined, and what is their nomenclature, what are the different categories of the air masses, how these air masses influence the weather and climatic conditions globally and influence the weather conditions of a particular local region also. So this was all about air masses. I hope the video was informative. Thank you.